Hello, am I audible? Can anyone please confirm whether am I audible or not?
Yes, please. Yes, yeah, you are very much audible.
Okay, thank you.
Yep.
So, good evening everyone. I am Riya Tupwal. I am doing my PhD under the supervision of Professor Sudeep Mishra at IIT Kharagpur. Today we will discuss the topic of week 9 and after that we will discuss some questions of same week. Last week we discussed about cloud computing, which means storing and manipulating programs and data over the internet instead of hard disk of your computer. Today we will continue with the same topic and after that we will discuss about sensor cloud and then about fog computing. So okay, so today we will discuss about OpenStack. So basically OpenStack is a cloud OS that is used to control the large pools of computing, storage and network resources within the data center. It is an open source and free software platform. This is essentially used and implemented as an infrastructure as a service for cloud computing. Last week we discussed about infrastructure as a service, in which the cloud service provider provide infrastructure to the end user. Basically infrastructure can be your hardware, operating system, all those things. Okay. It is launched as a joint project of Rackspace Hosting and NASA in 2010, and presently many companies are contributing to OpenStack, such as your IBM, Cisco, HP, Dell, VMware, Red Hat, SUSE, Rackspace Hosting, and many others. So basically it is a very large community, and if you also want to contribute, then you can also make changes in the code and contribute to the formation or in the creation of cloud. There are various versions of OpenStack, such as your Austin, Baxter, Cactus. So basically these are in alphabetical order. So till 2022 Z was the last version of your OpenStack. Now recent version is Bobcat, which is in development phase, and before this Bobcat, Antelope was developed. Now in this figure various components of OpenStacks are shown, such as your Horizon, which is your dashboard, then Nova, Glance, Swift, Neutron, Cinder, Heat, Ciliometer and Keystone. Now we will discuss about these components one by one. Yeah. So first component is your keystone. So it is the central repository of all the users and their permissions for the OpenStack services they use. This is a component. This component is basically used to manage the identity services. For example, your authorization, authentication, AWS styles, logins, token based system, and checking other credentials of the end users. For example, your username and password. So basically this component is responsible for authenticating the users. Next component is your horizon. So this is the first component that the user sees when he or she will open the OpenStack. Horizon is the web user interface component which is used to access the other backend services which is provided by your OpenStack. Through individual API, developer can access the OpenStack's components, but through the dashboard system, administrator can look at what is going on in the cloud and manage as per their need. Next component is your Swift. So Swift is used to store and retrieve the arbitrary data in the cloud. Object storage is used in this. In Swift, basically, it is possible to store the files, objects, backups, images, videos, virtual machines, and other unstructured data. So developer may use a special identifier for referring to a particular file or objects in the place of path, which is directly point to that particular file, and allows the OpenStack to manage where to store that particular file. Next one is your Nova. So Nova is the compute service basically, and this is this is a controller that is used to manage resources in the virtualized environment. It handles various virtual machines and other instances that can perform computing tasks. Next one is your Glance. So Glance is responsible, or it is a component that is used to provide image services to the OpenStack. Here image services means image or virtual copies of your hard disk. So when we plan to deploy a new virtual machine instance, then Glance allows us to use these images as a template, and Glance allows VirtualBox or VMware virtual images to perform the same. Then the next one is your Neutron. So basically Neutron is responsible for providing the networking services and enables the other services to communicate with each other. So with the help of Neutron, one can also make their own network. Anyone is trying to say something? Any question? Okay. Next is your Cinder. So this works in the traditional way of attaching and detaching the external hardware to the operating system for its local use. So basically Cinder manages to add, remove and create new disk space in the server. So basically these components provide virtual storage for the virtual machines in the system. Next is your Heat. So Heat is responsible for providing the yes.
Ma'am, one doubt, ma'am. What is the difference between object storage and block storage, ma'am?
Basically object storage here means to store the various these files and all those things, and here block storage means it is providing the external storage space to your OpenStack. So basically Cinder is responsible for managing the external storage spaces, that is your block storage.
Okay.
Yeah.
Okay, ma'am.
Yeah, so next one is your Heat. So Heat is responsible for providing the orchestration. Orchestration here means the automation of various services which is provided by your OpenStack. So it allows the developer to store the cloud applications which necessitates as a file, so that all important resources are available in handy. So basically this component organizes the complex applications of the cloud through the templates which is provided by the OpenStack. Then next one is your Ceilometer, which is also called as telemetry. So it is used to meter the usage and report it to OpenStack's individual users. So it tells about the amount of resources you have used, what services you have used, and how long you have used those services. And for all those services, telemetry is responsible for billing these things. So these are the main components of your OpenStack. Apart from these components, there are some other components also. For example, your Manila and Sahara. So Manila is your shared file system which offers storage of the file to the virtual machine. This component gives an infrastructure for managing and provisioning the file shares. However, your Sahara is elastic map reduce. which offers simple method to the users to pre-plan the Hadoop cluster by referring to the multiple options such as your Hadoop version, cluster topology, hardware details of the nodes, and some other things also. So basically these two components are not that much useful, so the components which I have mentioned in the slides are important. After this, the next topic is your sensor cloud. So as the name suggests, sensor cloud, so what does this exactly mean? So basically it is not just the integration of your sensor technology and your cloud computing, and it was also not dumping of the sensors data into your cloud. So basically first picture is showing that sensor cloud does not mean the integration of your sensor technology with your cloud computing. That is the synergy of your sensors and your cloud. So sensor cloud does not mean the synergy of your cloud with your sensor technology. The second is, it is not just storing the data of your sensors into the cloud, or offloading the data of your sensors into the cloud. So if it is not the integration of sensors with your cloud computing, and if it is not dumping of your sensor data with your cloud, then what exactly your sensor cloud means? So basically in case of your cloud computing, so basically in case of your cloud computing, what happened is there are various resources which are available, and with the help of virtualization concept, the end users can use those resources, and a particular resource can be used by multiple users at the same time with the help of multi-tenancy features of your cloud computing. So same is the concept of your sensor cloud. So what happened in sensor cloud is there is a concept of virtualizations of your sensor node. So basically a single sensor node or a particular sensor node can be used by multiple users at the same time. So basically that particular sensor node is virtualized, and multiple users can use that particular sensor nodes for performing different tasks. Now similar to cloud computing, where the end users have to pay for the particular service they are using, and for the amount of time they are using the particular service, same is the case with your sensor cloud, and the end users have to pay for the sensors they are using. So one sensor node can be appeared as many. This is similar to the virtualization concept of your cloud computing. Same hardware or same resource can appear as many. So similar to that, in case of your sensor cloud, one sensor node can be appeared as many. Now a stratum between sensor node and end user is there. After that, the virtualization concept. So what exactly is virtualization? So I hope this is clear to all, because this thing we have already discussed in your cloud computing. So basically in case of your virtualization, a single resource can be appeared as multiple resource with the help of, or with by using the concept of virtual machines. So basically it improves the throughput and cost by using physical resources as a pool from which virtual resources can be allocated. Now what are the benefits of using this virtualization concept? So first one is your sharing of resources. So same resource can be shared by multiple end users. So this results in the reduction of cost. Second one is your encapsulation. So complete computing, so there is a complete computing environment is there in case of your virtualization. Then independence, then all the virtual machines which are created over the single resource works independently. And next one is your portability. So with the help of virtualization, we can migrate your virtual machines from one system to other. Now in case of your so this table is showing the difference between your wireless sensor networks and sensor cloud. So as we know that in case of your wireless sensor networks, there are basically three components. So first one is your sensing component, second is your computing component or processing component, and third one is your the component which is responsible for communication, right? So wireless sensor networks are used in order to sense the environment, and accordingly the data which is sensed, some analysis is performed, and then the decision is taken over that. Now in case of your traditional wireless sensor networks, a particular sensor which we are using or a group of sensor which we are using for a particular application cannot be shared by multiple users at the same time, right? However, in case of your sensor cloud, with the concept of your virtualization, you can use a group of different end users can use a group of sensors at the same time. So basically the ownership in case of your wireless sensor network, only the wireless sensor network users are the owners. In case of your sensor cloud, sensor owners are the owner of your sensors. Then the deployment in case of your WSN users are responsible. Then in case of your sensor cloud, sensor owners are responsible for deployment. Then for redeployment of wireless sensor for your wireless sensor network, users are responsible. And for your sensor cloud, SCSP, that is your service providers are responsible for this. Then for maintenance also, in case of your WSN, only the end users are responsible. However, for sensor clouds, different users are responsible for different features. For example, for ownership and deployment, sensor owners are responsible. Redeployment, maintenance, overhead, your SCSP are responsible. And for usage, end users are responsible. Now the difference between your WSN and your sensor cloud. So this figure is showing the difference between your traditional wireless sensor networks and your sensor cloud. So first figure is showing the traditional wireless sensor networks, where the various or a group of sensors are sensing the environment, and the aggregated data is used by your wireless sensor networks user. So this is also that particular data which is sensed by a group of sensors is dedicated to particular single user or a particular application. However, in case of your sensor cloud, there are multiple sensors, and these sensors are virtualized, so multiple applications or users can use the data which is sensed by this sensors which are present in your sensor cloud. Now the actors of your sensor cloud. Actors means the various users of your sensor cloud. So first one is your end users. So end users are the end users are the users who are going to use the data which is sensed by the sensors. These users are unknown about what and which physical sensor is allocated to which particular application. So they don't know about the virtualization of sensor. They are just taking the data from the sensors sensor network and utilizing that data for different applications. The second component is your sensor owner. So a sensor owner, as the name is suggesting, that these are the users who own the sensors. So they play a role for from business perspective. They purchase physical sensor devices, deploy them over the different geographical locations, and lend these devices to the sensor cloud. The next one is your SCSP, that is your sensor cloud service provider. So these are the business sectors which charge the prices from the end user based on the usage of these sensors. So basically these service providers are responsible for the billing purpose. So they will take care of the the sensors which are available in the network. So they will lend these resources to the end users and check the amount of time the end users are using the resources, and they will also check for the different types of sensors the end users are using, and based on these characteristics they are going to charge the price from the end users. Now the example of your sensor cloud service provider which are there are, for example, your cloud service provider, there is AWS, Microsoft Azure. So similar to that, there are some sensor cloud service provider, for example your AWS IoT, Microsoft Azure IoT, Google Cloud IoT, IWM Watson IoT. So these are some examples of your sensor cloud service provider. Now the architecture of your sensor cloud. So this figure is showing the architecture. So as I have discussed that there are three different actors, that is your end user, sensor owner, and your service provider. So basically these end users are going to use the data which is sensed by your physical sensors. They don't know about the virtualization of your sensor. So basically they are just going to access the data with the help of web portal. The second actor is your SCSP, which is responsible for the virtualization, for pricing, caching, management, composition. So all the managerial tasks are performed by your SCSP. Then the third is your sensor owner. So sensor owners are going to deploy various sensors at different locations, and after that they are going to lend these sensors to the sensor cloud. Now the management issues in the sensor cloud. So there are various management issues in the sensor cloud. First one is your optimal composition of your virtual sensor node. So optimal compositions mean, so basically your virtual sensor node doesn't mean a single sensor, so it can be a group of group of different sensors, right? So what should be the optimal composition? So what are the different types of sensors that we should include in your virtual sensor? How many numbers of different types of sensor we should use in your virtual sensor? So this is the first issue that is need to be considered. So optimal composition of your virtual sensor nodes. Second one is your data caching. So basically in case of your wireless sensor networks, it is not always required that the values which is sensed by your sensor is going to change, right? For example, if you deploy a temperature sensor at a particular location, then it is not necessary that the temperature value is changing frequently. So if your sensor is continuously sensing the environment, then then the lifetime of the sensor will be less, right? Or if the end user is continuously fetching the data from the sensor itself, then the lifetime of that particular sensor is less. So there should be a technique that a particular sensor value should be cached at the sensor node, and sensor node should not always sense the value in order to provide the data to your end user. So there should be some techniques which will decide that when the sensor should sense the value and when the sensor should provide the cached value to the end user. So the decision that when the sensor should actually sense the environment and when it should provide the cache value, so it is one of the issue. Then next one is your optimal pricing. So the pricing that that will be beneficial to your end user as well as to your service provider. So basically there should be maximum profit to your service provider, and the end users or the services which is provided by your service provider, the end user should be satisfied by those. So there should be a proper optimal pricing policy which will satisfy both your end user as well as your service provider. So these are the three management issues related to which are there in your sensor cloud. Now now the two different views of your sensor cloud. Yeah. So first figure that is at your left hand side is your user organization view, and second one is your real view. So basically user organization view means the view which the end users will get, that how your end user is going to see your sensor cloud. However, the figure which is at your right hand side, that is your real view, will show that what exactly happened in your sensor cloud. So basically, first of all, we will discuss about your user organization view. So in case of your user organization view, what happened is the users can access the sensor cloud with the help of your browser template. So basically, these user, first of all, the user have to log in, and he has to give the template specification, that in which template he is going to access the data for the particular application. So user is going to provide that to your browser. Now browser will give the particular template based on the specification, and also provide the sensed information, which it is actually taken from the physical sensors. Now the user is going to use this sensed information for different application. So basically for end user, what he is going to do, he is going to just log in, provide the template specification, and further your browser is going to handle all those things. This is what user is going to see, end user is going to see. But in actual, there are various other components also which take care of different things. For example, the servers, your service providers will take care of your dynamic scaling, your on-demand physical sensor scheduling, energy management. So all these things take place. So basically, whenever your user will log in and provide your template in specification, various tasks will take place at your physical end, where energy management will take place, how different resources will be scheduled, and how different sensors will be given to different users. These things will take place. Then XML interpretation will take place, dynamic scaling will take place, and further the data will be taken from the heterogeneous pool of your physical sensors, and that data is provided to your end users further. So basically, in case of your end user view, these things are not known to your end user. However, in actual, these things will take place at your sensor cloud. Now the formation of your virtual sensors. So efficient virtualization of physical sensor nodes is required, and optimal compositions of your virtual sensors is required. Now how we can achieve this? So first one is your considering the same geographical region, and second one is your spanning across multiple region. So basically, whenever you are going to form your virtual sensor, so you can consider all the sensors which are present at one particular location, right? And you are going to use those sensors in order to form a virtual sensor. This is the first scenario, and these sensors can be homogeneous as well as heterogeneous. And second case is the case where you are using heterogeneous sensors which are located at different locations. So in this figure, you can use this virtual sensor 1 is formed by different sensors which are located at different physical locations, right? So basically, okay, consider a case whenever you are going to monitor the health of a machine. Okay, so if you want to monitor the health of the machine, you have to use different sensors, right? For example, your temperature sensor, your humidity sensor, vibration sensor, accelerometer, right? So whenever you are going to form a virtual sensor for monitoring the health of the machine, you have to use a composition of different kinds of sensors, and the number of the amount of sensors may also vary, because if you want to monitor the health of machine, then you have to place different temperature sensors over different positions of your machine, right? So that particular virtual sensors can be formed by the compositions of different sensors, as I have mentioned. So these sensors can be present at a single location, for example over the machine, and there might be a chance that these sensors are present at the in some other application scenario, these sensors might be present at the different locations. Now, why the composition of virtual sensors are required? So first is resource constrained sensor nodes. So basically sensor nodes are resource constrained devices. They don't have enough memory, enough processing power. So we need so in order to form a virtual in order to perform a task efficiently, we need a composition of different sensors which can perform the task efficiently. Second is dynamic change in the sensor condition. So basically due to some environmental changes or due to some error in your sensor, a single sensor cannot provide accurate reading. So we require different number of sensors in order to get efficient reading or efficient sensing of your environment. So for that purpose, a composition of your sensors is required. And third is composition of your virtual sensors are non-traditional. So in case of your basically what does this composition of virtual sensors are non-traditional mean? So basically this the data which is sensed by your virtual sensor is not traditional. It is not the data which is sensed by a single sensor. It is the combination of different types of data or composite data which is sensed by different sensors, and that data is merged, and then the analysis is performed over the composition of these data in order to get the particular analysis. Now the caching mechanism in your sensor cloud. So dynamic and adaptive caching mechanism in your sensor cloud. So it introduces internal and external caching mechanism which ensures efficiency in resource utilization. So basically it is flexible with the varied rate of change of the physical environment. Now why caching is required in your sensor cloud? So basically whenever end user requests for I have already discussed this with so whenever you are going to whenever end user is going to request for the data, so if the sensor is going to provide the data frequently, or if it is continuously sensing the environment, then the lifetime of that particular sensor will be less. So there is a need of a technique or a method by which the sensors can provide the data which is already cached or stored at the sensor node. So if that particular sensor is not continuously sensing the environment, then the lifetime of that particular sensor can be increased, right? So for that purpose caching in sensor cloud is required. So basically end user request for the sensed information through web interface, then the allocation of physical sensor nodes and virtualization take place. Physical sensor nodes continuously sense and transmit the data to the sensor cloud. So basically this happen in the traditional case. Now practically in some cases the change in environmental condition are significantly low. So due to this low change in the environment, the sensed data of physical sensors are unaltered, and in such situation unnecessary sensing can cause energy consumption and reduces the lifetime of that particular sensor. So in this scenario it is better to provide the cached data to the end user. Now there are two types of caching mechanism which is present in your sensor cloud. First one is your internal cache and second one is your external cache. So internal cache. So internal cache handles the request of the end users, and it takes decision whether the data should be provided directly to the end user or is it required to recache the data from the external cache. And then the external cache. So basically after every certain interval of data are required to recache, initially few data are used to be transmitted to internal cache. So basically this is similar to your memory system. So the end user asks for a particular data, your cache is going to provide the data to, if that particular data is present in the cache, then the data is provided to the end user, and if it is not present in the cache, then it is the request is sent to the main memory. So somewhat similar to that scenario only, there are two caches present, and after that there are physical sensors. So basically this internal cache will decide that whether to provide the data from this internal cache only, or we need to refetch the data from the external cache, and this external cache is responsible for recaching the data after regular interval of time. Now this is the figure showing the difference between the existing architecture and the cache enabled architecture of your sensor cloud. So basically, in case of your existing architecture, these are the applications which are requesting the data from your sensor cloud. Here various sensors are deployed, and this sensor cloud is responsible for the virtualization of these sensors and provide data to different applications at the same time. However, so whenever different applications want data, so physical sensors will provide the data without after sensing the environment. However, in case of your cache enabled architecture, it is not required always to send the data from the physical sensors only. So whenever applications want data, your internal cache is going to provide the data to your applications, and it will decide whether to take the data from the external cache or not, or whether to provide the data directly to the different applications. So these two the usage of these two, internal cache and external cache, is responsible for minimizing the delay in order to provide the data to the different applications, and also it is responsible for maximizing the lifetime of your sensors. Now the dynamic optimal pricing for sensor cloud infrastructure. So basically, existing schemes consider the homogeneity of services. For example, your infrastructure as a service, software as a service. So basically, there is no scheme present for your sensor as a service. And there is a need to propose some pricing scheme for your sensor as a service. So basically, this scheme comprises of two components. First one is your pricing attribute to hardware and pricing attribute to your infrastructure. So the goal of proposed pricing scheme is to maximize the profit of your service provider, to maximize the profit of your sensor owner, and to maximize the end user satisfaction. So basically, the pricing policy should be like that: your end user should be satisfied, and the profits of your service provider and sensor owner should be maximum. Now the pricing policy focus on maximizing the profit made by your SCSP, optimal pricing to the end user. So end users have not to pay much amount of money, and they should be satisfied with the services which are provided by your service providers. And this pricing attributed to hardware deals with the usage of physical sensor nodes. However, your pricing attribute to your infrastructure deals with the price associated with the infrastructure of your sensor cloud. Now the next topic is fog computing. So fog computing or fogging is a term which is coined by Cisco. The idea behind fog computing is to extend the cloud nearer to the IoT devices. So basically, the main problem with the cloud computing is the delay associated with the fetching of data from the cloud or offloading the data to the cloud. So in order to resolve this problem, fog computing was introduced, where the services which are provided by your cloud computing are placed nearer to your end devices or your IoT devices. So basically, the primary aim of your fog computing is to solve the problems faced by cloud computing during the IoT data processing. So basically, the problem is latency. An intermediate layer between cloud and devices are placed. So that intermediate layer is your fog. So 40% of the whole world's data came from sensors alone. So this is the data of your 2020. So and 90% of the world's data were generated only during the last two years. So basically 2.5 quintillion bytes of data is generated per day. So total expenditure on IoT devices will be was 1.7 trillion by 2020, and the total number of connected vehicles worldwide was 250 millions by 2020. So in order to manage that amount of data and in order to process that amount of data, there is a need of intermediate layer which is going to reduce the latency which is provided by a cloud. So this particular layer, which is the intermediate layer between your end users and your cloud computing cloud layer, is your fog layer. So the ability of the current so the ability of So the ability of the current cloud model is insufficient to handle the requirements of IoT, because in case of your IoT, real-time processing is required. For example, consider the case of vehicular networks, right? Where the real-time analysis of the data is required in order to analyze the traffic, in order to prevent the accidents that are taken place on over your roads. So in that case, real-time analysis of the data is required. So if you are going to use cloud computing in that case, then cloud computing is going to add a delay in that scenario, right? So basically, in order to prevent that delay, or in order to prevent the accidents that are taking place due to this delay, there is a need of intermediate layer, right? So that fog computing is going to provide. So basically the issues are that is related to your cloud computing is volume. So basically a large amount of data we need to offload to the cloud, and then we need to download the large amount of data from the cloud. So latency is involved in order to fetch the data from the cloud. Then the bandwidth requirement in order to offload the data and download the data is large. So basically these are the three main issues. So first one is your data volume. So as I have already discussed, that the amount of data which is produced by your IoT devices is large, and and the density of the devices that we are using is increasing day by day. So the current cloud model that is not using fog computing is unable to process this amount of data in the real time. So basically these private firms, factories, airplane companies produce large amount of data every day, and current model cloud model cannot store all these data, and that data need to be filtered at the cloud end. So the existing cloud infrastructure is not able to perform that. The second one is your latency. So latency here means the time taken by the data packet for a round trip. So basically the time taken by to offload the data, and further to fetch the information based on the analysis of that particular data. So in case of your cloud computing, that is your traditional cloud computing, the latency will be the amount of data, that is T from device to cloud. So the data in order to offload the latency or the time taken to offload the data to your cloud, then the time taken by the cloud in order to analyze the data, that is your T data analysis, and further based on that analysis some decision should be taken, right? So the T from cloud to device, so the time taken by that decision to move from your cloud to your device. So total latency will be the summation of these three. So basically in case of your cloud computing, when the data servers are placed far from your end users, the latency will be increased, because the time taken to offload the data will be large, the time taken to download the data will be large, because it will depend upon because basically it is the propagation delay, right? So it will depend upon the distance between the end users and your cloud servers. So if in case of your cloud computing where the servers are far from your end user, this propagation delay will be large. So here fog computing is required, because in case of your fog computing the data is placed near to your end user, so the propagation delay basically will get reduced in case of your fog computing. Next one is your bandwidth. So yeah, so as your end devices are producing large amount of data, so in order to transmit that large amount of data to large distances, the requirement of bandwidth is also large, right? So in order to reduce the requirement of bandwidth, there is a need to propose a intermediate layer between your end devices and your fog and your cloud. Then the requirements of IoT. So basically what does your IoT require, why there is a need of intermediate layer? So first one is your reduced latency of data. So in case of your IoT network, there is a need of reduced latency of data. So appropriate action should be taken at the right time in order to prevent the major accidents such as machine failures or other accidents. So basically a minute delay while taking a decision can make a huge difference. So latency can be reduced by analyzing the data closer to your end devices. The second one is your data security. So the IoT data must be secured and protected from the intruders, and the data are required to be monitored 24/7. So an appropriate action should be taken before the attack causes major harm to the network. Next one is your operation reliability. So the data generated from the IoT devices are used to solve the real-time problem, and the integrity and availability of data must be guaranteed. So unavailability and tampering of data can be hazardous. So basically if you are not if you are using cloud computing, only cloud computing, so there are some chances that due to delay the data is not available, so it may result in various accidents. The next is processing of data at respective suitable places. So basically extremely time sensitive data should be analyzed near to the data source only, or near to the places where data should be used. So if that data is placed far away from the end users, then it can result in various accidents. So data which are not time sensitive can be analyzed at the cloud. So basically in case of your IoT, there should be categorization of data. So the data which so there should be a categorization of data on the basis of time sensitiveness. So the data which is time sensitive should be analyzed or processed near to the end users, and the data which is not time sensitive can be analyzed at the cloud only. Next one is your monitor data across large geographical area. So the location of your connected IoT devices can be spread across large geographical region, right? So for example, monitoring of railway track over the country. So for this the IoT devices will be deployed over the country. So these devices are exposed to different environmental condition, and the environmental conditions at different locations are maybe harsh or not. So depending upon that, the data monitoring should be done at large geographical areas in case of your IoT. So there is a need to analyze the data over different geographical regions depending upon the environmental condition. The next one is your when should be used fog. So okay, so there is a need to decide then when we should use fog, and when there is no need of fog computing. So if the data should be analyzed with the fraction of time, with the fraction of second or with the fraction of time, then there is a need of fog computing. If there are a huge number of devices that we are going to use in order to perform some task, or if there are huge number of end devices, If the devices are separated by large geographical distances, then there is a need of fog computing. If the devices are needed to be subjected to extreme environmental conditions, so for example, in this case only, so if you have deployed the end devices over different environmental condition, then there is a need of fog computing, which is going to analyze the data at different locations. Now the architecture of fog computing. So here in this figure, as you can see that there are basically three layers. First one is your IoT layer, second one is your fog layer, and third is your cloud layer. So in case of your fog computing, cloud services are extended to the IoT devices with the help of your fog. So fog is the layer between cloud and IoT devices. So basically here you can see, as this is the intermediate layer between your IoT devices and your cloud, many fog nodes are can be present. So it is not necessary that there is only a single fog node. So there can be different fog nodes which are going to analyze the data of your IoT devices separately. So this fog layer is going to reduce the latency, save bandwidth, and save the storage of the cloud. Now the characteristics of fog node. So first one is your storage. So first one is your storage. So basically the storage which is provided by your fog computing is transient. Basically it is not permanent. So the data which is stored at your basically the memory which is present, or the storage which is present at the fog layer, is less as compared to cloud. So the complete data cannot be stored at the fog layer. So only the small amount of data can be stored at the fog layer. So basically the data which is used frequently by the end user is stored at the fog layer, and the data which is not necessary or which is not frequently used by the end user is stored at the cloud. So basically there is an exchange of data between your fog layer and your cloud. So this fog layer does not provide permanent storage to the data. So basically it will store only the data which is frequently used by the end user. So this fog layer is similar to your cache memory which is used. Okay, so similar to your cache memory, as your cache memory store the frequent data only, similar to that thing only, your fog layer is going to store the data which is frequently used by the end user. Second one is your computing facility. So fog layer also provide computing facility. It is going to perform it is going to process the data which is generated by the end user, and based on that processing it is going to take decisions. So to process the data before it is sent to the cloud to take quick decisions. So this fog layer is basically used to take the quick decisions based on the processing which is done by the fog nodes. Next one is your network connectivity. So fog nodes are also responsible to connect with your IoT devices and other fog nodes and cloud. So basically these nodes can be connected with each other. These different fog nodes can be connected with each other. These are connected to cloud also, and these are connected to your end devices also. Now as I have already told you that in case of your IoT we need to categorize the data. So basically there are three types of data that can be used. First one is your very time sensitive data, next one is your less time sensitive data, and then data which are not time sensitive at all. So based on this categorization, it can be decided that which data can be processed at your fog node and which data can be processed or analyzed at your cloud. So basically fog node works fog node works according to the type of data they receive. So an IoT application should be installed at each fog node, and the nearest fog node ingests the data from the devices. So basically the fog node which is nearest to the devices is going to process the data and going to take the decision on the analysis of the data. So basically the most time sensitive data are processed at the nearest fog node, and if the data is less time sensitive, and see in case of your fog nodes, for example, consider that there are various devices here, right? And the nearest fog node is already occupied, so it has already some it is already doing some tasks. So if that particular fog node is going to process the data, then it can results in delay also, and it doesn't have that much amount of resources so that it can perform multiple tasks at the same time. So if the data is less time sensitive, then the other fog nodes which are there, that is aggregate fog node, can perform the analysis of data, and based on the decision which is taken by the aggregate fog nodes, the decision can be taken and sent to the end devices. And if the data is not time sensitive at all, then that data can be sent to the cloud, and then the cloud will perform the analysis and take decisions accordingly. Now this table is showing the difference. So basically the fog nodes which are closest to the devices, so the time taken by these fog nodes for analysis is a fraction of seconds. However, the fog aggregate nodes can take seconds to minutes in order to analyze the data. However, cloud can take hours to the weeks. Then the IoT data storage duration. So in case of your fog node which are closest to the devices, the storage is transient. In case of fog aggregate nodes, it may vary from hours to days, and for clouds it may vary from months to years. So it depends upon the end user for the amount of time they want to store their data in case of your cloud. Then the geographical coverage. So the fog nodes which are close to your end devices, the coverage which is provided by them is very local. However, fog aggregate nodes provide wider coverage as compared to the fog nodes which are closest to the devices, and in case of your cloud, the coverage is global. Now these are some advantages of using fog computing. First one is your security. Fog computing provide better security, and fog nodes can use the same security policy as used by your cloud computing in order to secure the data from the intruders. The next is low operational cost. The data are processed in the fog nodes before sending to the cloud, so basically it will reduce the bandwidth consumption, as in case of fog, bandwidth consumption is less, so operational cost will also be less. The next one is it reduces the unwanted accidents. So latency in case of fog computing is less, so due to which quick decisions can be taken, and the unwanted accidents can be reduced. Next one is your better privacy. So every industry can analyze their data locally with the help of your fog computing. They can store confidential data at their local servers without sending to the cloud, and send only the data which can be shared, and send the data which is not prone to these security threats to the cloud. The next one is your business agility. So fog applications can be easily deployed according to the tools which are available, and can be deployed anywhere we need. So they can be programmed according to the need of the end users. Next one is your its port mobility. So the nodes which are there in so the fog nodes can be mobile, so they can leave and join the network at any time. Next one is deployable in remote places. Fog nodes can be deployed anywhere in various remote places, or can be deployed in the harsh environmental conditions also, and these are also responsible for better data handling. It can operate with less bandwidth data can be analyzed locally, and it reduces the risk of latency. Now the applications of your fog computing. So first application is real-time health analysis. So basically, in case of your healthcare sector, you can use fog computing. Then for intelligence power efficient system, you can use fog computing. Then your windmill turbine analysis, you can use fog computing. Real-time rail monitoring, you can use fog computing. Pipeline optimization, you can use fog computing. For vehicular network, you can use fog computing. Then for industrial scenario where you want to analyze the health of the machines, you can use fog computing. So basically, whenever you need less latency, you can use fog computing in that case. Now the challenges. So first one is your power consumption. So basically, in case of your fog computing, you are going to use additional nodes, right? And these nodes are going to use power which is extra in case of your cloud computing. So basically, the power consumption in case of your cloud fog computing is more as compared to your traditional cloud computing. Next is your data security. So basically, these fog nodes are resource constrained devices. They cannot provide that much amount of security as can provided by your cloud, because they cannot run that much heavy computationally intensive task or intensive these security algorithm which can be performed by your cloud computing. And then next is your reliability. So maintaining the data integrity and availability for millions of nodes is difficult in case of your fog computing, and the failure of node cannot affect the network. Next is your fault tolerance. So failure of node should be immediately fixed in case of your fog computing. So individual failure should not affect the whole scenario. Then the programming architecture. So basically, these fog nodes are mobile, so there is a need to handle this mobility, because any node can join or leave the network at any time. So there should be need to handle this thing, that what happened when a particular fog node is going to leave the network. Then there should be need to perform some programming changes in the network. Then real time analysis. So real time analysis is the primary requirement for minimizing the latency. So dynamic analysis and decision making reduces the danger and increase the output. So monitor huge number of nodes in case of your fog computing is not easy, because your fog nodes are also not does not have that much amount of resources. Now the question, but before questions, I want to discuss that after fog computing there is edge computing also, which is, so in case of your edge computing, there is an intermediate layer. Fog computing is an intermediate layer between your cloud and your end devices. In case of your edge computing, one more intermediate layer is placed between your fog and your this end devices. So basically, in case of your edge computing, the processing is performed at the edge only, at the end devices only. So there is no need to transfer the data. In case of your edge computing, there is no need to transfer the data to the fog node. So the data which is very time sensitive, so the processing of that particular data can be performed at that particular device only. So that is the concept of your edge computing. Okay, and now question, but before question, I'll take a break of 2 minutes, and after that I'll start. difference between your edge computing and your fog computing. So basically, in case of your fog computing, the data is offloaded to the fog nodes, which are going to perform the analysis over the data, right? So basically, these fog nodes are going to process the data which is taken from different devices or different sensors. However, in case of your edge computing, this processing is mainly performed over those devices only. For example, if you are going to analyze the data over your mobile phone only, which is also generating the data, so it will be the example of your edge computing. And if the data is sent to a particular location which is near to your place, and over that server the processing is performed, then it is the case of your fog computing. So basically, edge computing is the, or edge layer is the layer between your end devices or your fog devices. So in case of your edge computing, some different nodes can also be deployed between your fog servers and your end devices, which are going to perform the analysis of data. So basically, the distance between your edge devices and your end devices is less as compared to the distance between your fog devices and your end devices. However, mainly the however, in case of your edge computing, mainly the processing is performed over your end devices only. So there can be two cases. So basically, if you are going to perform the analysis or processing over your end devices, then it can also be considered as the case of your edge computing. And if you are going to place some external nodes in between your fog nodes or the end devices, then it will also the case of your edge computing. For example, see, if you are going to place some fog nodes over the city, right? Because cloud computing, in case of your cloud computing, the servers may be present globally, and if the nodes are present over a city which is going to analyze the data, then it will be the case of your fog computing. And if the nodes are placed in your particular location only, or the other case
We
is,
are not able to see your screen, ma'am.
yeah, because
Ma'am, we are not able to see your screen.
I'm not
Sharika.
yeah, I'm not sharing my screen.
Okay,
I'm
okay.
just replying to the question which was asked.
Okay.
Okay. So basically, in case
Okay,
of
okay,
your
okay.
edge computing, the data is processed over the end devices only. Clear?
It is not that clear actually, but it's okay. You can continue. No issues. I will try to find out the answers.
What is the confusion?
For me, I am unable to find out the difference. I know the similarities, but I'm not able to find out the subtle differences between edge and fog computing. Because if let's say I put a ESP32 board near a device, so that could also become an edge computing. And the same thing, same if I put a ESP32 near another device, that could also be considered as a fog computing. So I am really not able to differentiate or find out any difference between both of them.
See, basically, the main difference is based on the physical distance between your sensor or the end devices and the nodes which you are going to place. Okay, so
No,
if
I'm sorry. I am sorry. I that point I really cannot agree because there cannot be a terminological difference just because of the physical distances.
see
That
in
I am very sure.
yeah, because in case of your edge computing, the processing is performed mainly over your devices only. Basically, your mobile phone is going to generate data. If you are performing the analysis over the same device, then it is the example of your edge computing.
Okay.
And on the other hand, where you are using some other devices in order to perform the analysis, which are placed from which are placed at some distance from your end devices, then this is the case of your fog computing.
What if I use my mobile phone for analysis? That also becomes a fog then.
No, then that your mobile phone is going to generate the data, it is also analyzing the data, then it will be the example of edge computing.
Why not a fog computing? That is my question.
See, if you, fog computing means there is an intermediate layer between your edge end devices and the cloud. So it is, the processing is not performed at the end devices. What is the difference, what is the definition of fog? Fog is the layer which is placed between your end devices and your
Cloud and device
cloud, right?
and
So
sensor.
the definition is not the processing is performed at the end devices. Okay. So basically with edge computing, the data is analyzed on the sensors itself, or on the actual device
Now
itself.
let's say I have a Blink. Blink is a cloud and I have a mobile phone. So that also becomes a fog then.
How?
That is the reason I'm getting confused. Blink is,
How it will become fog? Hello? Hello, am I audible?
yes, please.
Yeah. Can you please repeat that how it will become a fog? Because I have lost my connection. I was not able to hear.
See, I have a Blink application and I have my mobile phone and I have a Arduino device.
Okay.
So the Arduino device is connected to a sensor, say,
Hmm.
let's say it's connected to a DHT.
Hmm.
So my mobile phone, I control the Arduino using a mobile phone, and there is a cloud in between because I connect it through a Blink, and then through Blink I connect the to the Arduino
Hmm.
through ESP8266 interface. So if that is the case, then I still have a mobile phone, which is like a kind of fog again. I can consider that as a fog as well.
No, so no, you cannot consider that as a fog.
Why not?
Because the definition of fog is the processing is not performed at the same device. In case of fog, the processing is performed at some different device. If the processing is performed at the same device only, then it is the case of your edge computing.
Okay, so then in that case, my ESP8266 becomes the fog.
Yeah, if you are performing the some processing over that, then it will become.
Okay, then put it this way then. So I have a camera on my mobile phone, and my camera and my phone also can act like a. I can program my phone in such a way that I can start capturing the motions that are captured in the camera. So the camera is a sensor, the mobile phone becomes a device. So why not that becomes a fog computing again?
Can you please repeat? That sensor is sensors are there in your mobile phone, right?
Correct.
Yeah.
So I process whatever the sensors capture. I process them in my mobile phone because my mobile phone also has a processor, and through mobile phone I can definitely connect to the cloud as well. So why not my mobile phone become a fog computing then?
Yeah, because in that case, the sensor which you are using is placed over your mobile only. So the processing is done locally at the same device only. Where you are capturing the data or where you are collecting the data, on that same device you are processing the data also, right? So it is the case of your edge computing. So the correct terminology for this case will be your mobile phone will act as your edge node, not your fog node. So there is not much difference between your edge computing and fog computing. Only the terms are different. In case of your fog, if you are sending the data to some different device, then it is the example of fog. And if the processing is done locally over the same device, then it is the case of your edge.
Ma'am,
Yeah.
ma'am, what is the actual definition of computing?
Definition of fog computing. So fog computing is to bring the services which are provided by your cloud computing nearer to your end devices. So in case of your fog computing, one intermediate layer is placed between your end devices and your cloud computing, and that particular layer, the nodes which are placed in that particular layer, is going to provide the services which are provided by your cloud.
Ma'am, those layer whose are present in the fog computing, please tell me the layer of this.
What?
Wow, which layer present in the fog computing?
For in case of fog computing, three layer. One is your end layer, then fog layer, then cloud layer.
End layer, then second one is
Fog layer,
fog layer. No, ma'am.
fog layer, FOG,
Fog layer, then next.
Cloud
cloud
layer.
layer.
Thank you, ma'am. Continue.
Okay. So difference is clear.
I think I'm kind of getting it, but I will have to further think over. So for now, thank you very much. I think I got it. Thank you.
Okay. 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 Now we will discuss the questions. So first question is, OpenStack is a proprietary and closed source software that you have to pay and buy. Options are true or false.
Ma'am, your screen is not visible.
Oh,
False.
okay. Wait, I'll share my screen. Yeah. So open source is a proprietary and closed source software that you have to pay and buy. True or false? Please reply because it will be difficult for
False.
me.
False.
False. Okay.
False. Ma'am.
Okay. Huh. So this statement
So
is
open
false because open source is an open
source.
software. Okay. Next question is, in OpenStack, which of
Ma'am, please repeat the question number one.
So
Thank you, ma'am. Continue.
Okay. Next question is, OpenStack. In OpenStack, which of the following component takes care of user authentication? Options are Nova, Origin, Keystone, none of these.
C.
C.
C,
Keystone.
ma'am.
Okay. Anyone else? Which component is responsible for user authentication? Previous session link. Okay, I'll share after I'll cover the questions. Anyone? Okay, so correct option for this is Keystone. So this is responsible for providing the user authentication and authorization. Next question is, you cannot ping your OpenStack instance from an outside network unless you connect your instance with the public network through a options are router, firewall, repeater, load balancer.
Router.
Router. Okay.
Yeah, ma'am.
Okay. Anyone else? Router. Others also reply, please. You can check your notes also. Okay, so correct option for this is router. Next question is, what is the primary service model for sensor cloud? Options are hardware as a service, platform as a service, data as a service, sensor as a service.
Ma'am, option D, sensor as a service.
Okay. Anyone else?
D. D, ma'am.
D.
D.
Sensor as a
Sensor
service.
service.
Yeah, this is correct. Sensor as a service is the correct option. Next question is, you can run two logical computers, one Linux machine and one Windows machine on the top of same physical hardware through the use of, options are sharing, scaling, virtualization, inheritance.
Virtualization.
Virtualization. Okay. Anyone else?
C.
C. So virtualization is the correct option. So with the help of virtualization, multiple logical instances can be used over the same hardware. Next question is, in sensor cloud, one physical sensor can be abstracted as multiple virtual sensors. Options are true or false.
True, ma'am.
True. Okay. Anyone else? False. So this statement is true. So in case of your sensor cloud, particular sensor can be used as multiple virtual sensors. So different applications can use same sensor at the same time in your sensor cloud.
Sorry to interrupt. Just one question. Let's say I have a physical DHT sensor. So how can I interpret a DHT sensor as a camera sensor or a
No, no.
or
This question doesn't mean कि it can act as different kind of heterogeneous sensor. Basically, this
okay.
question mean कि that particular DHT sensor can be used by different users or different applications at the same time. So one DHT
Okay.
sensor can act as multiple DHT sensor at the same time.
A question could be interpreted in the other way as well. I interpreted in the other way.
Yeah, okay, but this question doesn't mean that it can act as your camera sensor or some other sensor. It means that that particular sensor can be used by different applications.
But that word homogeneous is missing actually, because we could take interpret even as a heterogeneous, as a multiple virtual sensors.
I haven't prepared these question. I just taken these
Yeah, I
questions
understand.
from your
I
previous.
understand.
Yeah,
I
yeah. So
understand. We will move on.
yeah. Next question is, in a sensor cloud framework, the end users have to continuously worry about owning and managing the physical sensor devices. True or false?
False, ma'am.
False. Okay.
False.
Anyone else? False. Others also please reply. In sensor cloud framework, the end users have to continuously worry about owning and managing the physical sensor devices.
False.
False. Okay. So this statement is false. So end users doesn't have to worry about the managing of your physical devices. Next question is, virtual sensors within a sensor cloud have communication interfaces with blank. Options are only the physical sensors below them, only the end user applications above them, both physical sensor and applications, neither physical sensor nor the applications.
Option
C.
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 Okay. Anyone else?
C, ma'am.
C. Okay. Yeah. So basically, virtual sensors can interact or interface with your applications also, and the physical sensors also. So basically, the data which is sensed by your physical sensors, this virtual sensors are going to provide that data to multiple applications at the same time. Next question is, which of the following is true? Option A is, in case of your traditional WSN, virtualization support is there, and in case of your sensor cloud, virtualization support is there. In case second option is, no virtualization in your traditional WSN, however there is virtualization in your sensor cloud. Third is, there is virtualization in WSN and no virtualization in sensor cloud. Fourth is, no virtualization in both WSN and sensor cloud.
Option E.
Option
A.
A.
Yes.
Okay, there is virtualization support in traditional WSN. Then what is the difference between your traditional WSN and sensor cloud?
B, ma'am.
B. Okay. Basically, if
Ma'am,
there is
ma'am,
virtualization, yes,
what is the full form of WSN?
wireless sensor networks.
Okay, ma'am.
So basically, if there is virtualization in both the cases, then what is the difference between your sensor cloud and traditional WSN? There will be no difference, because the main concept of your sensor cloud is virtualization only. So sensor cloud provide the virtualization of the physical sensors which are there. So option B is correct. So in traditional WSN there is no virtualization, however in case of your sensor cloud there is virtualization of the physical sensors. Next question is, okay. An organization ABC wishes to have environmental monitoring parameters of a particular region but does not have the resources to deploy its own physical sensors. However, another organization B has some physical sensors that monitor the environment deployed in the region. Can sensor cloud help in achieving the A's objective? Options are yes or no.
Yes.
Yes. Okay.
A, ma'am.
Okay.
A, ma'am.
Others? Okay. So the correct option for this is yes. Next question is, referring back to question number 10, based on your answer, determine the role of organization A and B that play in the given scenario. So A will act as sensor owner, B will act as end user. B option is A will act as end user and B will act as sensor owner. C is both A and B are sensor owners. D, both A and B are end users.
A.
A, that A will act as sensor owner and B is your end user. Okay, let's check. A wishes to have but doesn't have. So A does not have resources and B
Have
has
the
the
resources.
resources. Okay,
B has
which is correct
B.
option? B.
B.
Okay. Others also reply. Yeah, so correct option is B, because A does not have the its own resources. It is going to use the resources of B. So B will act as the sensor owner and A will act as your end user. So correct option for this is B. Next question is, which among the following is a limitation of cloud computing? Options are, first is on demand services, virtualization orchestration, C is large amount of computing and storage resources, additional communication latency for critical application.
D.
D.
D, ma'am. Right.
Okay. Anyone else? Others also please reply. What is the limitation of cloud computing?
Madam, what is the answer of question 11?
Question 11. Wait. So question
Okay,
11.
ma'am. Okay, ma'am.
Fine.
Fine.
Okay. So the limitation of your cloud computing is that there is additional communicational latency for your critical application. So D is the correct option for your question number 12. Next question is, in fog computing, the fog layer acts as an intermediary between the data source and the cloud for immediate processing of time critical data. Options are true or false.
True. Yeah.
Okay. Anyone else?
True.
True. Yeah. So this statement is true. Basically, in fog computing, one intermediate layer is placed between your cloud computing and your end devices, and the time sensitive data is processed at that particular layer. Next question is, suppose the one-way communication latency from the device to fog layer is 20 ms, and that from the device to cloud layer is 50 millisecond. The data processing time at the fog is 10 millisecond and at the cloud is 5 millisecond, after which a reply is sent back to the device by the fog or cloud. What is the difference between the total communication latency uh, for both your cloud and your fog respectively? All of you please calculate. So you have to calculate the difference between the communication latency in case of your fog and in case of your cloud. You have 5 minutes. All of you please use your copy and pen and tell me the difference.
C. 55.
55 milliseconds. Okay.
Say 55. C.
Okay, let's wait for others response also. You only have to sum these values: the time to offload the data, download the data, and the processing time for both your fog and cloud, and then calculate the difference.
Answer A.
A.
Yes.
Okay.
Ma'am, please can share this PDF too.
Yeah, I'll upload this over the drive link. The link is same only which I have shared previously. I'll share again. Once again, I'll share.
It's vanished, ma'am. So
Yeah,
it's
I'll share once again. Okay. Mm. So the correct option for this is option C, because the total communication latency for cloud is, see there, the one way communication latency for cloud is 50. So round trip time will be 2 into 50, that is 100, and the processing time is 5. So total communication latency is
50
1.
plus.
What? Can you please repeat what you are trying to say? Okay. So the total communication latency for your cloud is 105 millisecond, and for your fog it will be, for fog layer, 20 millisecond is one way latency. So two way latency will be 2 into 20, that is your 40, and the processing time is 10. So 40 plus 10 is 50. So the difference is 105 minus 50, that is your 55 millisecond. Fine. Next question is, which among the following is true? Fog computing act as a complement to cloud computing. Fog computing is a replacement to cloud computing. Fog computing and cloud computing are same. Fog computing is more powerful than cloud computing. Anyone? This is very simple question.
option
A,
A.
ma'am.
A. Fog computing act as a complement to cloud computing.
A.
Yeah, A is correct option. Next question is, the OpenStack cloud simulation framework provides an interactive GUI. True or false?
A, ma'am.
A. True. Okay, and what's the name of that GUI?
Yes.
What is the name of that GUI?
Ma'am, please repeat the question number 15.
Question number 15. Which of the following is true? Fog computing act as complement to cloud computing. Fog computing is a replacement of cloud computing. Fog computing, cloud computing are same. Fog computing is more powerful than cloud computing.
Okay, ma'am, continue.
Okay. So this statement is true, and the GUI is, anyone? The name of the GUI.
Graphical user interface, ma'am.
I'm not asking the full form. The name of the GUI which is provided by OpenStack. What
Ma'am,
is the name of the dashboard? So Origin is the GUI which is provided by your OpenStack. So the name of the GUI is Origin.
ma'am, I can understand, ma'am.
Windows RX.
What?
Windows RX.
I'm not getting. Your voice is breaking. Can you please repeat?
Graphical user interface.
Basically, there are different components of OpenStack. One of the component is Origin, that is the graphical user interface of your OpenStack. So I was asking the name of that graphical user interface. So the name of the graphical user interface for OpenStack is Origin. Fine. So Origin is
Ma'am, the graphical user interface of the OpenStack is one of the parties Origin.
yeah, right.
But ma'am, in the assignment, one question is arise, that is the which of the some options are there, and the question itself, which of the not a part of the OpenStack, and the options are plasma, origin, etc. etc. But here is the option are plasma is the not a part of the OpenStack,
हाँ, so
ma'am.
हाँ, तो plasma is not a
Ma'am,
component of OpenStack. So what's your question? I'm not getting your question. See, the different components are neuron, glance, swift, cinder, origin, keystone, nova, and nova also. So plasma is not a component of your OpenStack.
yes ma'am, plasma is not a component of OpenStack. एक तो assignment 8 में question आया था इसका.
Okay.
This question is repeated in your presentation.
Okay.
Ma'am, please back these questions on GUI. True. Okay, continue.
Next question is virtualized resources within the OpenStack simulator that you can define, set parameters of, and deploy within OpenStack are also known as instances, files, hypervisors, sketches.
Ma'am,
Instances.
in the previous question, GUI example
What? In the previous question?
question, you are asking the example for GUI.
Not, I'm not asking the examples. I'm asking the name of the GUI.
Name.
Ma'am,
What is the
please,
name, madam?
ma'am,
Origin.
What's the
H O
name?
R I
or
Z O N.
ma'am,
Orisa.
Yeah.
hello,
Yeah.
ma'am.
Yeah.
Uh,
Ask.
Okay.
please give me some details about the OpenStacks.
See, I have already discussed this thing in the starting of this video lecture. First of all, let me complete the questions, and if time will left, then I'll again give you the details. Otherwise, you can check the video lecture. Okay.
Okay, sure, ma'am.
Yeah. So yeah, question number
Ma'am, please
17.
send that PDF
Yeah, PDF I'll
drive.
share.
Ma'am, please send me the PDF, but PDF are not shared in this group.
I have already given you the link last time also. Wait. After this session, I'll upload the PDF to this.
Ma'am, please send me all this PDF in my WhatsApp contact number.
That I cannot do. I'll share the link with you. You can access the all the PDFs from this link.
लिंक्स अभी तक कोई लिंक्स नहीं आया मैम.
I have shared in the chat box.
और चैट बॉक्स में
Week 9 is not there, ma'am. Only week 8 session.
Week
week
9 after this session I'll upload week 9 also.
okay ma'am.
Okay.
But
Where I'll get.
ma'am here is no link found ma'am.
What?
Hello. Here is no link, any type of links found in this.
I have given the link in the chat box.
Chat
I have
box.
again shared.
Okay. Yes ma'am.
Okay. So click over there. You will get all the PDFs from week 1 to week 8, and after this session I'll upload the PDF of week 9 also.
Okay ma'am. But here is the only one PDF chat box.
No. This is the link of folder. In that particular folder you will get all the PDFs.
Okay ma'am.
ठीक है.
ये मैम कब तक रहेगा मैम. हेलो.
हाँ, ये अभी तो रहेगा जब तक सेशन चल रहा है, जब तक एग्जाम नहीं होता तब तक रहेगा.
Can I download this PDF
हाँ, you can
before
download
this?
the PDFs.
अच्छा.
Okay, I'm continuing now. So question 17 was virtualized resources within OpenStack simulator that you
Ma'am,
can.
ma'am, after this classes over, this PDF should be deleted in my phone or not?
No, PDFs will not be deleted. period. If you will download the PDFs, then this will not be required. But after this course, I will delete the folder from my Google Drive.
But
Okay, so it will be better
save
to
how
download the
should
PDFs.
save this PDF? I have no idea, ma'am. ये तो लिंक्स में आ रहा है सब कुछ.
हाँ, लिंक पे क्लिक करो. लिंक पे क्लिक करने के बाद यू
हाँ
विल
लिंक
गेट ऑल
में
द
क्लिक किया
पीडीएफ.
ना, वो सारी PDF आ चुका है मैम. उसके
हाँ,
बाद क्या करना है मैम?
उसके बाद वेट, मेरा स्क्रीन दिख रहा है. बेसिकली यू हैव टू क्लिक, राइट क्लिक करना है. राइट क्लिक करने के बाद डाउनलोड का ऑप्शन दिखेगा.
PDF डाउनलोड होगा फाइल. हाँ मैम, वीक 8 का जो एवरी शुड बी डाउनलोड ऑप्शन आ रहा है. हेलो.
हाँ, वहाँ से डाउनलोड कर लो.
ओके मैम, एवरी अप टू वीक मैम. हेलो मैम,
हाँ,
यहाँ पर वीक 1 एंड वीक 2 इज मिसिंग इन दिस PDF मैम.
नहीं नहीं, वीक 3 सबसे पहले है, देन वीक 1, वीक 2, वीक 4, वीक 5. चेक
हाँ
प्रॉपर्ली.
हाँ हाँ. वीक 5 is here मैम.
हाँ, week 9 after this session I'll upload week 9 also. So yeah, so the correct option for question number 17 is
मैम प्लीज प्लीज वन सेकंड.
Yes. Yes, ma'am.
yeah, A instances is correct option. You can download the PDFs later on also.
ओके मैम, हो गया मैम. प्लीज 1 minute.
Yeah.
Ma'am, can you send the drive?
Yeah, I have shared the link.
चैट बॉक्स में लिंक शेयर किया मैम.
Yeah, okay, he was asking in Hindi, that's why I was replying in Hindi only. So I have
Ma'am, I
shared.
should ask the questions in this PDFs. Which type of questions, MCQ questions, are arising in NPTEL examination?
What? Yeah, similar to these questions only you will get the questions in your exams.
Ma'am, but in this PDF, MCQ are not found, ma'am. It's only a theoretical questions, ma'am.
No, MCQs are there. In the starting, the summary of that particular week is given, and after that questions are there.
अच्छा.
Check properly. These are the PDFs which I used in these sessions only.
ओके मैम, बट मैंने सब फास्ट में सिर्फ समरी चेक किया था मैम, और कुछ नहीं मैम.
Yeah, so
1 2
questions are there.
3
Questions
4
are there. Check properly. Let me complete first. After that, we can discuss these things.
ओके मैम.
Next question is, if you want to connect your OpenStack instance with the external public network, you would need to connect the following between your instance and public network. Options are database, file, memory, router.
मैम 1 minute मैम.
Router.
Router. Okay.
मैम
Database.
Database.
मैम क्वेश्चन नंबर 17 मैम. मैम
हाँ.
हेलो मैम.
Yes, yes, yes. Please बोलो.
क्वेश्चन नंबर 17
Yeah, I have.
इंटरप्शन. हाँ. नहीं, क्वेश्चन नंबर 17 का रिपीट चाहिए था. 18 कंटिन्यू कीजिए.
So yeah, this is 18th question. If you
क्वेश्चन
want
नंबर
to
18 में जाइए. 17 का
18, can
आंसर
you
में
please?
देखना था,
Okay.
इसीलिए बैक के बोला. हेलो.
Okay, mute yourself now. I'm reading the
Hello.
question. Hello. Okay. So
हेलो.
anyone? Yeah, please mute yourself. I am reading the question now. Hello. Am I audible? Yeah, week 9 I'll upload after this session. So the correct option for this question is router. Next question is, which among the following is not a part of a sensor
Yes, ma'am.
node?
I mute myself, ma'am.
Yeah. Which among the following is not a part of sensor node connected to wireless sensor networks? Options are sensing unit, gaming unit, processing unit, communication unit. Anyone?
If you upload this week 9, then you share the links of this chat box.
Yeah, I will upload and you will get through the same link. Okay. So in your sharing folder you will get that particular folder, and from there you can download the PDF for week 9. So okay, reply for this question: sensing unit, gaming unit, processing unit, communication unit. Anyone?
मैम क्वेश्चन 18 का आंसर क्या है?
Question 18, router. Should I continue?
मैम व्हाट इज आंसर ऑफ क्वेश्चन नंबर 18?
Question number 18, D is the correct option, router. Is my screen not visible to you? Hello? Hello?
Yes,
Am I
ma'am.
audible now?
Yes,
Yes,
yes.
yes, ma'am.
Yeah, sorry, I lost my connection. Okay, so you were asking for the answer of question number 18. So router is the correct option, D.
Thank you, ma'am.
Okay. Next question is, which among the following is not a part of sensor node connected to wireless sensor network? Options are sensing unit, gaming unit, processing unit, communication unit.
B, gaming.
B, okay, gaming unit. Yeah, gaming unit is correct option. Next question is, consider that you have two types of sensor: soil monitoring sensor for smart farming and temperature sensor for smart industry. The concept that correct type of sensor must be deployed only at their correct and appropriate physical location suitable as per their functionalities is known as right way of deployment, right place of deployment, right time of deployment, none of these. A, right way of deployment. Okay. Anyone else? Deployment of sensors at appropriate physical location. So the correct option for this is right place of deployment, because it is asked that where exactly to deploy that particular sensor. Next question is, sensor as a service is an exciting new concept that brings service model of the cloud computing to traditional IoT sensor networks. In this aspect, which among the following forms an essential component of sensor as a service architecture? Sensor marketing, sensor division, sensor virtualization, sensor manufacturing.
C, ma'am. C, sensor visualization.
Right, sensor virtualization is correct option. Next question is, considering the end-to-end architecture of WSN from the physical sensor nodes right up to the user, sensor clouds support different entities to have ownership of the different layers and components simultaneously. Options are true and false. Anyone?
True, ma'am. True.
Right, this statement is true. Next question is, in sensor cloud architecture, the sensor cloud service provider is logically situated at the following position of the architecture: in the same level as the physical sensor, in between the physical sensor and user layer, in the same level as the user, none of these.
D.
D or B?
Between physical sensor and user layer.
Yeah, right, between physical sensor and user layer your SCSP is placed. Next is question number 24. In sensor cloud, the association between the virtual sensor instances and the corresponding physical sensors follows: one-to-one mapping, one-to-many mapping, many-to-one mapping, many-to-many mapping.
Option C, ma'am. Many to one mapping.
Option C. Why? One-to-many cannot
B,
be.
ma'am.
B होगा. One to many mapping में B होगा.
B.
Many-to-one cannot be performed. Basically it is many to many mapping, so it is not defined that one physical sensor can act as multiple virtual sensors, or so we can use multiple physical sensor as one virtual sensor and one physical sensor as multiple virtual sensor. So basically it can be many to many mapping. Next question is, dynamic caching mechanism improves the flexibility and efficiency of sensor cloud. Options are true or false.
Yeah, ma'am.
A, true. Yes, this
Correct.
statement is correct. Next question is, with respect to the caching based architecture of sensor cloud, the external cache has the direct data connection with which among the following: internal cache, user application, physical sensor, both physical sensor and internal cache.
Yeah, ma'am.
A. Okay. Anyone else? So correct option for this is, it should be A. I will check again. The answer was given as D, but your external cache is connected with your internal cache, and after that it is connected with your this sensor cloud, not with your physical sensor. Yeah, basically this sensor cloud is physical sensors only, so D option is correct for this. Okay, so external cache is placed between your sensor cloud and your internal cache, so D option is correct. Next question is, data from an IoT device is transferred to cloud by a network, which is then processed at the cloud, and then a response is sent back to the IoT device from the cloud after processing. The time it takes for one-way transfer between the node and cloud is 10 seconds, and the data processing time at the cloud is x second. It takes total of 2 seconds for entire to and fro transfer of data between the sensor and cloud. Then what is the value of x? So basically total time is given, one way communication time is given, you have to calculate the processing time. Anyone?
C, ma'am. C.
C. 15. Okay. See, one-way communication is given. So you have to calculate the round trip time. That is 2 multiplied by one-way communication. So 2 multiplied by 10 will be 20. So 20 plus processing time should be equal to 25. So your processing time will be 25 minus 20. That will be your 5 second. So B is correct option. Next question is, there are two types of sensors data, A and B. A is time sensitive, that is required to be processed immediately, and B is not time sensitive and can tolerate longer time for processing. As per the standard utilities of cloud and fog, which among the following options shows the correct processing locations for A and B? A should be processed at cloud and B at fog. A at fog, B at cloud. None of these, both of these. A is time sensitive and B is not. Anyone? B is correct option because A is time sensitive, so it should be processed near to the end devices. So A should be processed at fog and B can be processed at cloud. Next question is, there are multiple fog nodes in between physical sensor layer at the bottom and the cloud at the top. True or false? Anyone? So the correct option for this is true. Next question is, which among the following is
Wait for a few minutes. Now she joined.
okay, I have lost the connection. Hello? Hello? Am I audible?
Yes, ma'am. You are
Yes, ma'am.
audible.
Okay.
Yes,
Yes,
you
ma'am.
are audible.
At which question I have lost the connection?
20.
28 or 29, I think so.
28.
Okay,
28.
28th question is, A is time sensitive data and B is not time sensitive data. So what are the correct location for their processing? Okay, so A should be processed at fog and B should be processed at cloud. So this was the 28th question. Fine.
Ma'am, your screen is not visible. Question screen is not visible.
Okay, wait.
Question screen not visible, ma'am.
Wait. Now fine.
No, ma'am.
Still not visible.
Yes.
Now it's visible.
Ma'am, screen share. Ma'am.
I have already shared my screen.
No, ma'am.
Networks.
Yes,
Ma'am,
visible.
visible,
Yes,
ma'am,
visible.
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 Yes.
Okay. Okay, so question number 28 was, A is your time sensitive data and B is not time sensitive data. So you have to decide the location for their processing. So options are, A should be processed at cloud and B at fog. A at fog, B
Ma'am,
at
again
cloud.
cut up again. Excuse me, ma'am.
Wait.
Excuse me, ma'am.
Excuse me,
Visible
ma'am.
or not?
Ma'am, your screen is not visible.
Is it visible or not?
No, ma'am.
I have already shared.
No, ma'am.
No, ma'am,
No,
not
ma'am.
visible.
No.
Okay, let me complete, and after that you will get the video link over YouTube.
I think
Okay.
ma'am network issue, ma'am.
I think there is network issue. You will get the complete questions at YouTube link. Only two questions are left. You can hear me. I'll speak a little slow. Okay.
Okay.
Yeah.
Okay, ma'am.
So question number 29th is, there can be multiple fog
Ma'am,
nodes.
only two questions are. Yes, ma'am.
There can be multiple fog nodes between physical sensor layer and cloud layer. True or false? I'm repeating, there can be
There can be.
multiple fog nodes
Ma'am,
between
ma'am, ma'am, please tell us slowly. There can be multiple.
fog nodes
No.
in
Mm,
between the physical sensor layer and
between
the cloud layer.
hog nodes between.
Physical sensor layer and cloud layer.
The physical sensor.
Layer and cloud layer. Cloud.
And
Physical
cloud
sensor
layer.
layer
Yeah.
Physical sensor layer and cloud layer.
Right.
and cloud. Ma'am, options.
Options are true or false. Is my screen visible now?
Yes, ma'am, visible.
Yeah.
True.
True. Yeah, this statement is true. Next question is, which among the
Ma'am,
following
ma'am, ma'am, please repeat the your questions.
So
Hmm.
this is question number
Continue.
29. Yeah.
Hmm. Continue.
Next question is, which among the following is or are true potential problem and challenge in fog computing? Options are power consumption, data security, liability, all of these.
Ma'am, 29 number repeating, ma'am.
Yeah, it should be 30th. Okay. So there is problem in numbering. You focus on
Okay, ma'am.
all of
Okay,
these.
ma'am.
Yeah, all of these is correct option for this. Okay.
Okay, ma'am.
Yeah.
Ma'am, please share me the PDF of week 9.
Yeah, I will upload now. One person has asked me question last week that the objective is, keep the overhead tank filled with certain liter of water all the time by topping up when it falls below certain threshold and stopping when the water is nearing the top. So he is using material water pump, relay unit, Arduino board, contactless water sensor. So he has some problem with the approach that he should take. So first question was, use wireless sensor relay with electric motor for actuation controlled by Arduino and contactless water sensor at the overhead tank. So basically, if you want to check the level of your water tank, you can use various types of water sensors. For example, you can use ultrasonic sensor, capacitive sensors, or your optical sensor in order to check the level of your tank. So here he can use relay over your this electric motor in order to control the electric motor. So whenever your water tank is filled, that particular sensor is going to check whether the tank is filled or not, and based on the level of the tank, the relay can control the motor. So basically it can switch off and on the motor based on the level of the tank. Second question he was asking is, he is not sure whether he should use blink for this automation or not. So here this is the detailed answer for first question. You can read this later on. Second is that whether he should use blink or not. So basically blink is an app based platform that allows you to control or monitor the Arduino projects remotely using your smartphone or tablet. So basically, in order to use a blink, you need to install the blink app over your device, and after that you can create your new project, blink project. Basically this blink can support various types of Arduino board. And here in this project you can use blink in order to send push notification or alerts to the end user related to the water level fall. So basically blink can be used in this particular project. So second question is whether he should use blink or not. So blink can be used. Next question is, can I use wireless ultrasonic sensor to detect the water level? Yes, he can use ultrasonic sensor in order to detect the water level. If so, would it be possible to connect wireless ultrasonic sensor and Arduino board so as to place it close to relay and motor, thereby eliminating the need of wireless relay? Basically you can connect your ultrasonic sensor with your Arduino board directly wirelessly without placing the relay, but it is always better to place relay in between, because a relay is going to monitor the current which is getting. So basically if you are going to directly connect the sensors and Arduino board, then it may result in the that your sometime your microcontroller will get overloaded due to the power which is it is getting, and it may sometime burn also. So it is always suggested to place relay in between your this sensors and your Arduino board. However, you can also connect these directly. So these was the answer. You can go through in detail after this, and I'll upload the PDF after this session. So okay, it's already 8.
Ma'am,
So
please upload to week
yeah,
9
I'll upload within 5 minutes. I'll upload. So
week 9
in
and
the
week 8.
same in the same link you will get.
Okay, ma'am.
Yeah. Okay, thank you.
हेलो
मैम
मैम
चैट बॉक्स में लिंक शेयर करेंगे
No, no, no. The link which I have shared is the valid link only. I'll upload, and you can get the PDF from that link only. The link which I have shared with you.
मैम नॉट चैट बॉक्स
Chat box is not required. I have already given the link to you.
ओके मैम
Yeah,
Hello,
in
ma'am.
that
Thank
link
you, ma'am.
only you can get. Yeah, okay, thank you.
हेलो
थैंक यू
मैम
मैम
Yeah,
मैम
yeah,
गुड इवनिंग मैम मैम जो आपने कोड लिखकर भेजा था
हाँ,
लाइन फॉलो के लिए मैम उसने वर्क किया था, बट मैंने मैम डिफरेंट लेफ्ट राइट और फॉरवर्ड के लिए जब मैंने मोटर स्पीड की अलग अलग वैल्यू डाली तो वो लाइक वो पाथ में थोड़ा लिटिल डेविएशंस आने लगे
okay.
मैम। उसके लिए क्या कर सकता हूँ लाइक
Deviations in what form? Deviations means?
लाइक कि वो पाथ सही से फॉलो नहीं कर रहा था जब मैंने डिफरेंट डिफरेंट मोटर स्पीड वाली जो कमांड होती है वो मैंने लेफ्ट फॉरवर्ड और बैकवर्ड और इन तीनों में अलग अलग डाली तो वहाँ अलग थोड़ी गड़बड़ हो रही थी एंड जस्ट मैंने इनिशियल स्टेप में जस्ट उसको 150 पे सेट किया तो वो सही थी एंड जब मैंने अलग अलग तीनों कंडीशंस में किए तो वो डेविएट हुए थे।